The notes for Unit 7, Lesson 3 will cover solubility curves. So the first part of the video today will talk about the different vocab terms that we have with solubility. And then the second part will show you these solubility curves, which is a graph, and how to read those. So in the digital notebook, you will have to answer questions about solubility curves. So the second part of the video will help with that. So make sure you have your notes with you. We are on page 2 of the notes if you're using the notes packet. About halfway down section 16.1 with solubility. So here are some of the vocab terms. So 3 factors that increase the rate at which a solute will dissolve. One is you can stir the solution or agitate, which means to shake it. That will increase the rate at which the substance will dissolve. Second thing you can do is increase the surface area. So if you have a chunk of sugar or a chunk of something, you can break it up into smaller particles and increase the surface area. And that will cause the substance to dissolve faster. And you can also heat the solution because heating increases the kinetic energy of the molecules, and then that since the molecules are moving faster, they're going to break down the substances that they're trying to dissolve. So those are the 3 ways that you can increase the rate at which a solute will dissolve. So 3 terms that you'll see are saturated, unsaturated, and supersaturated. Saturated, like if you think about in the spring or winter, like when the ground is frozen and we have all this melt off from the snow, the ground gets saturated, so it's either frozen or it's saturated to where it cannot hold anymore, and that's when you get these, flash floods or, excess water drainage. So saturated means that the solution can't dissolve any more of the solute. So a solution that contains the maximum amount of solute at a given temperature is saturated. So if you have salt and you put it into water, you put the salt in, stir it up, it all dissolves, you add more salt, stir it up. When you add enough salt, the solution is not going to be able to hold a specific, up to a given point of salt. So once those salt particles start to fall to the bottom and don't get dissolved, that means your solution is now saturated. So you've met the point of saturation. Each substance, which I'll show you on the graph, kind of has its own solubility curve. And so different substances you can dissolve different amounts of substances into water depending on their properties. Unsaturated is a solution that contains less than the maximum amount. So if you have a container of water, you put a little bit of salt in, all the salt dissolves, the solution can hold more salt. That would be an unsaturated solution. So unsaturated means it's under its saturation point or it's under its solubility mark, and the solution can hold more solute if needed. And then the last term is supersaturated. So supersaturated means the solution contains more than the maximum amount at a given temperature. So like if you were going to make homemade syrup or homemade caramels, you have to heat up the solution to get all of that sugar to dissolve. So that's a supersaturated solution. If you have like a sucker or a lollipop, they have to heat up the solution to get all of that sugar to dissolve. And then once it cools back down, usually those supersaturated solutions will easily crystallize because they contain so much solute that they'll just crystallize. So when you guys are looking at your graphs, you will be looking at solubility. Solubility is a measure of the amount of solute that will dissolve into a specific amount of solvent, usually it's water, at a given temperature. So when you're looking at these solubility graphs, the solubility is measuring how much solute you can put into a specific amount of water at a given temperature. The solubility graphs that you will look at, the unit for solubility is in grams of solute per 100 grams of water. So all of these samples would be dissolved into 100 grams of water. All right, so that's it for the vocab piece. Now I'm going to show you how to read and how to interpret these graphs. So this is a picture of a solubility graph. It's got a bunch of lines. So if you notice, the colored lines represent the specific chemicals that are the same color. So Ki has a very different solubility than KClO3. So just recognizing that different substances have different solubilities. So you can dissolve way more potassium iodide into a solution of water than you could potassium chlorate. Most substances will increase with increasing temperature. So as you can see, the x-axis, the temperature increases and most of these lines go up. However, some of them, a few of them, will slope downward to have a negative slope. So these are the graphs that you'll interpret. Usually solids will increase their solubility as temperature increases. Usually gases, the solubility of gases will decrease. All right, so here are some questions that you'll see in your notebook when you're reading these solubility graphs. So solubility curves tells us if a solution is saturated, unsaturated, or supersaturated. If it's saturated, that means the substance contains the maximum amount of solute at a given temperature. So if you look at the example on the bottom, if you had 110 grams of KNO3 dissolved into 100 grams of water, usually the question will say, at what temperature can you dissolve 110 grams in? So if you're looking at KNO3, here's my turquoise line. So if you're right on the line, here's our 110 grams of solute, and you go over to the KNO3 mark, and then if you follow it straight down, we can see that at 60 degrees Celsius, we can dissolve 110 grams of KNO3 into a solution if we wanted to make a perfectly saturated solution. So if the mark of solute and temperature is directly on the line of solubility, that means a solution would be saturated. If it's unsaturated, so again, we are looking at KNO3 as the example. So we're looking at this turquoise line. So this time we took 80 grams of solute dissolved into 100 grams of water at 60 degrees Celsius. So here's our 80 grams of solute at 60 degrees Celsius. And so the mark would be here, which is under the KNO3 line. So if the point at which your solute and temperature is under the solubility line, that means the solution is unsaturated. So we could add more KNO3 to the solution and it should all dissolve at that temperature because this mark is under the solubility line. So supersaturated gets a little tricky. So I'll kind of explain the two things with supersaturated. Supersaturated means the substance contains more than the maximum amount. So if the mark is above the line, the saturation or the solubility line, then that solution has more than the maximum amount dissolved into it, as long as it's all dissolved. So that's the key with supersaturated. If you're dissolving more, you have to, like all of the solute would have to dissolve in order for it to be supersaturated. So if we dissolved 130 grams of KNO3 at 60 degrees Celsius, our mark would be here. This mark, or this point, is slightly above the KNO3 saturation point. So since we're dissolving more at that given temperature, then that would be a supersaturated solution. So those are the things that you'll look at as you're reading the graph. The problems will either give you the amount of solute, and then you have to figure out at what temperature it would dissolve, or it'll give you the temperature, and then you have to figure out, how much solute it can dissolve. So hopefully this helps. Let me know what questions you have.